My name is Tanushika Singh. Currently, I am pursuing my BTech in Electronics and Communication Engineering at KIT Group of Institution. I am also enrolled in ASIC and Full Custom Layout Trainee at PinE Training Academy. It's a pleasure to be here to present our project, Automated Corner Analysis using Bash and SQL. Before starting the whole presentation, I would like to invite my teammate Kavya Tayal to please introduce himself. Over to you, Kavya.
Thank you, Tanushika. Hello, everyone. My name is Kavya Tayal. Currently, I am pursuing my BTech in Electronics and Communication at ABS Engineering College, Ghaziabad. And I'm also enrolled in PinE Training Academy as an ASIC and full custom layout trainee. Today, we have get an opportunity to introduce our project, Automated Corner Analysis, using skill and bash scripting in front of you all. So now, I would like to invite my teammate Tanushika to take you through the live presentation of the project. Over to you, Tanushika.
Thank you, Kavya. Let's start with the detailed presentation of our project. So every circuits that has to be worked, it must be tested under each and every condition, under the ideal condition, as well as it also has to be tested under the worst condition scenarios. There are three variations that are measure the factors of these are the process, voltage, and temperature. So let's see what exactly each variations work. So for example, the first variation is the process variation. So every manufacturing process can cause the deviations, maybe in the some threshold voltage, and these variation can lead to the differences in the delay of the project, delay of any circuit, and the power consumptions as well. So we need to simulate these circuits under the different processes. For example, in our project, we have used the 5 corners as the TT, FF, SS, FS, and the SF. Let's move forward with the second variation, that is the voltage variation. So there is always the fluctuation occurs in the power supply that can affect both the speed and power consumption of any circuit. So in the similar way, the circuits has to be tested under a range of voltage so that they can be work under the each and every conditions. Let's move with the third variation, that is the temperature variations. So in the similar way, temperature can also influence the threshold voltage, affect the performance of the any transistors. So it must be tested under the temperature because we do not know that under which conditions the circuit has to perform. Maybe it has to perform under a very high temperature, maybe at the 125 degrees Celsius, and maybe at very low temperature as minus 40 degrees centigrade. So yeah, let's move with the forward, that objective of a project, that what is the objective that we have chosen this particular project. So yeah, what is the why we have chosen this particular project? For example, that it reduces the manual effort. So before starting, it is the PVT simulation. Before starting and running any simulation, you have to set up the circuits and each and everything. So you have to again open the simulation and set up each and everything. So it basically from our project, you have to do each and everything from the bash cell, from the terminal. So it reduces each and every manual effort. Let's move forward with what is the second benefit. It is that there is no GUI dependency. No GUI dependency, what does it mean? It means that you do not need to open any Virtuoso. So there will be no requirement of any graphical user. You just have to type R command ACA from the terminal and whole project will run from the terminal. Let's move with the third objective, that is the license efficient. License efficient as such that when we are running the project from the terminal, so there will be no need to the license of the Virtuoso. And the most important, the other thing is that we are also plotting the graph from the terminal itself. So we do not need any Viva license for the same. Let's move forward. What is the current scope and the supported setup? What are the basically currently what are the supported things? What are the dependency of a project? So yeah, the first dependency is that it is the technology dependent. That is currently it supports only the GPDK 45 nanometer file. Yeah, in future we will definitely implement the other files also. The second one is the supported corners. So currently there are the 5 supported corners in our project. There's, as I have already mentioned you, that they are the TT, SS, FF, FS, and SS. The next is the tool dependency. So what is the tool dependency? Is that the path on which the user is currently working or executing a project, it must contain the Cadence Virtuoso, Spectre simulator, and the bash compatible cell at that particular path on the terminal. Let's move forward. What are the key features? So most exciting part is that what are the exactly key features of a project? So there are many key features, as I have mentioned, that template file setup, expression file setup, analysis setup, netlist generation, results extraction, DC operating points, signal plotting. Let's move forward and discuss about each features in detail. So yeah, template file setup. What is exactly the template file? You all have seen that before running any circuit, you have the circuit needs some inputs to be set up to run. For example, what will be the cell name, what will be the voltage, what will be the corner. In the similar way that you do in the Cadence Virtuoso after setting, in the similar way, the user have to make his template file setup or copy from our option that we have provided. That template file setup, what exactly the template file contains, that it contains what will be the simulation type. In the picture you can see that there is what will be the simulation type, you will choose what will be the library name, cell name, for example, in which particular library your project is present and which particular cell over which you have to run the project, and what are the corners, voltages, temperatures, stop times, sweep type, DC sweep type, or anything else. Okay, let's move forward with the further expression file setup. From the topic, I think you have guessed that what exactly this file setup contains. So yeah, expression, it will contain the expression. Now what expressions for what? Expression for the output, that compile in the starting of the project when you provide the template file, at the same time you will provide the path of the expression file. At any part you can make the expression file. So yeah, for example, if you have given the expressions for the transient analysis, in the AC analysis we have provided the gain for gain expression, where you can write the expression to find out the gain of the particular expression. And the one thing that if you have not chosen or written any expression file, then in the end of the project there will be no output will come in the result file. The simulation will run, but the expression output file will totally dependent on the expression that you have provided. One most feature is that, for example, if you have chosen the transient analysis as the simulation type, but in the expression file you have also written the expression for the AC or DC, then simply the expressions will be only calculated for the transient analysis and the AC and DC analysis type will be skipped. Let's move forward with the further. What will be the analysis setup? So yeah, analysis setup, once the template file will be set up and configured, all the analysis will be set up. And for example, in the DC sweep type, if you have chosen in DC sweep type component parameter as the sweep type, then you have to uh, enter the source name, start and stop source sweep value. In the similar way, if the simulation type you have chosen the AC sweep type, and in the AC sweep type you have chosen frequency as the sweep type, then you have to enter the start value of the frequency, and similar way the stop value of the frequency. Let's move forward with the further analysis, that netlist generation. For example, after each and every input file setup and all the setup has been set up, the netlist file will be generated for each particular PVT corners that you have mentioned in this. And what exactly this netlist file will include, that it will includes the library and cell info from the user that they have entered in the template file, what will be their simulation type, what will be their PVT, that is what they have entered as the process voltages and the temperature. And the one thing is that the path of the netlist that will be formed will be displayed on the terminal itself. So user can simply move to the copy this particular path and move to the particular file and see what exactly the netlist contains. Let's move forward with the results extraction. At the end, what the user exactly wants from the simulation file. The user wants the results, the output. So yeah, in our project at the end, after each setup, after the completion of the setup, the result, the simulation will run, and then the results will be extracted in the way that whatever the expressions you have entered in the expression file, the expression will provide you the output, and the output file will be generated at the end automatically. You will not need to do anything, and it will help you in debugging the any expressions or in comparing itself. One thing more, that the results will particularly totally dependent on the expression file that you have mentioned. If you will not provide any expression in the expression file, this particular result file will not be displayed to you, but the simulation will run. Yeah, let's move forward with this particular further. feature of this particular project, that is the DC operating point. So for example, in the DC sweep type at the analysis setup or in the template file, if you have not entered any DC sweep type, then the DC operating points will be present in the expression file and the output will be generated according to the DC operating point. So for example, here we have given the expression of the VGS of the NM0, that is NM0 is the NMOS any component of the particular circuit, and it for the by this particular expression you will get the VGS value of the NM0 NMOS. So let's move forward. What is the signal plotting? So yeah, our project, there will be no, as we have already mentioned, that there will be the no use to open any Cadence Virtuoso. In the similar way, all the signal plotting will no need of any Viva license. In this, the whole signal plotting will be done through the Firefox, and the signal plotting will also dependent on the expression file. For example, in the expression file, if you have entered the expression of the plot of any particular thing, any particular parameter, only then the plotting will be displayed to you. If you have not mentioned any plotting expression, this particular plotting will be skipped to you. So all this is the end of our presentation. Now I would like to invite my teammate Kavya to take you through the live demo of our project. Over to you, Kavya.
Thank you, Tanushika. Before we start the demo, let me ask you, have you ever struggled with the manually running simulations across multiple PVT corners? But this project which could help you this process to make faster and easier. In this demo, I will show you that how our project exactly does that. So let's start the demo part. So firstly, I will show you that what Tanushika said, how we can copy our template file in the same directory or the directory you want. So first of all, you have to write the keyword ACA for our project, then minus H switch for help. So if user doesn't know any of the switches used in the project, simply write ACA and press enter. So using ACA, here you can see a short help, a quick help of options will be displayed switches to the user. So here you can see minus H switch with the template file, with the particular template, the user can see the particular template on the terminal. Next, similar with the minus H and the expression switch. If user will pass any particular file, expression file search, it will display it on the terminal. Next, minus template switch and given the part template to provide the template file that is used in the project. If user wants to exit the project, user simply write minus exit switch. So now let's start how this all will implement it. So firstly, I will try AC minus H template switch. So when I use this switch and press enter, here you can see these are the number of templates which are present in our project. So if I want to see any of the particular template, that how the template looks like, how I want to make it, and then start the project. So for example, I want to see the template of tran_dc. So it is present on the number 6. So I will present 6 here and press enter. So here you can see the template of transient and DC analysis is shown here, which contains simulation type, cell name, library name, corners, voltages, temperatures, stop time as it is for transient analysis, and for DC analysis we have given DC sweep type. Here DC sweep type you have 3 parameters to sweep. One is the temperature, second is the design variable, and third is the component parameter. You can sweep any of them. So now here you can also copy from here, and we have also provided an option at last. If press yes if you want to copy to the current directory, press no if you don't want to copy, and press custom if you want to copy to a directory of your choice. So here you have to mention, if you press custom, so you need to mention the directory path. So moving forward, now we'll see how the expression files also look like as for the template file. So we'll see also write ACA minus H given that switch, and now for expression file you just simply write expression if you don't know the particular expression file and press enter. So here you can see these 8 particular expression files are being presented in our project. So you can see any of one using by pressing the number on given beside the expression. So for example, I want to see the expression file of transient_dc_ac, which contains all 3 analyses. So what I'll just simply do is press 6 and enter. So here you can see this is the expression file where we have firstly used hash transient and provide all the transient sweep expressions and plots expressions. Same for AC expressions and plots. Same for DC expressions and plots. This is how you can make your own expression file. So you can also copy from it here and name and make the expression file, or you can make by your own also. So now let's move forward and see how the analysis are being run through our project. So first of all, I'll show you how how the ACA analysis is being implemented through our project. So here I have given the ACA minus template switch with the template file. So here the template file is in the same directory, current directory. So I have only given the name here, minus expression switch with the expression file path. So after pressing enter, here you can see a quick introduction of our project is being presented here, and also the custom template file you have used and the custom expression file you have used. Here user has been asked, do you want to review the expression file before continuing or not? So let's see what does the expression files contain. So I'll press yes and enter. So here you can see in these expression files, hash AC is being written. So it is for AC analysis, the expressions for AC, plots for AC, and here we have also mentioned DC sweep also. So now I will show you that in AC, if we have chosen AC analysis, AC sweep type, so if DC expressions will be plotted or not, we'll check it. So we have seen the expression file, it is correct. So press enter to continue. So while checking the inputs from our template file, which we have entered, so it will take a few minutes, few seconds to just check all the inputs, and then it will move forward to the number of simulations on which our circuit, on which our project is being simulated. So here we have given the total number of simulations are 2. So how these simulations are being given to the project? So let's see. We'll check. So by pressing update, we'll check the number of simulations. So here, the simulations has been counted using corners, voltages, and temperatures. Here I have used one corner TT, one voltage 1.2, and two temperatures 25 and 125. So here one netlist will be generated for TT 1.2 volt and 25 degrees Celsius, and another netlist will be generated for TT 1.2 volt and 125 degree temperature. So let's see if the corners will be vary or not. So for example, we'll also give FF as a corner here and press save the file and move back. So here you can see now the total number of simulations has been changed to 4. So now let's continue with the number of 4 simulations by pressing continue. So here the analysis which we have set, the DC sweep type which we have given, AC sweep type which we have given will be analyzed if they are correct or not. And then after it will show that if we have used any design variable in our project, so that design variables will be listed. So see here again, setting up design variables, there is an option for here. So here there are 2 design variables available in our project. So in our circuit we have used 2 design variables. One is DC volt and another is AC amplitude. So let's enter the value of DC volt. So for example, I just entered a wrong value of DC volt, ABC. And for AC amplitude, I have mentioned 6 milli. So by pressing enter, it will show you that you have entered these values. If you want to continue with these values or update. So I want to update the values. So press no. So here we can also re-enter the values. So I'm re-entering the correct values. So DC voltage I'm taking 600 millivolt and AC amplitude is 6 milli. And now pressing enter. Now here I have chosen the correct entries. So I'm pressing yes to continue. Now here we have chosen AC sweep type as frequency. So here it will ask for the start value of frequency. Let's take 100 Hertz and stop value of frequency. Let's take 100 gigahertz. So by pressing enter, I want to continue with these values. So now here you can see the netlist has been generated, all netlist file has been generated for different corners, voltages, and temperatures. And the part of the particular netlist file is also being displayed here. Now there is an option for post-processing results. So now to calculate all the expressions outputs and the plots, the results has been post-processed, and then after the results post-processing, the output file will be generated and the plots will be generated. So now let's see, it will take some time. So here you can see our expression file, output file is being displayed here. So firstly see and go how our plots look like. So basically our plots has been run for TT corner. So see, here you can see our AC plot for different voltages, temperatures and corners which we have provided will be displayed one by one here. So see here the third plot is being displayed for which we have sweep. Now this is the fourth plot. So here you can see the comparison also, that here the value has been started from 14.2 or 3, and if we take a previous corner, here the value has been started from 10. So here you can also differentiate about all the variations has been done through corners also. So this is how you can check your plot variations, plot in the parameters. Next, we'll move to the output file. So in the output file, you can see our post-processing results on the with the date and the time is also being mentioned here. The result database path is being presented for every corner, voltages and temperature. So you can just go through that PSF directory and then check the particular result which you want to check. And the expressions files, which expressions you have entered in the expressions files has been displayed here with the results. So you might be thinking, where are the DC expressions gone? So here, if you have chosen the expression file, expression to be run as only AC, so no DC expressions will be plotted here. No plots also and no expressions will be calculated. So this is how our expression files output file looks like. Here you can compare the values for different PVT setups you have set here. Now, this is how our AC analysis will be run. So you might be all wondering if we can run all DC, transit and AC analysis at the same time. Yes, you can. So now let's check the same also. So now I'll be pressing giving the template file as tran ACDC. I have named this template file for my easiness. You can update the name as per your needs. Same with the expression file. I have given the expression file path and now pressing enter. So let's review the expression file before continuing. So pressing enter, here you can see all the transient AC and DC expressions are being presented here because we have running transient AC and DC analysis. If it doesn't want to give any particular parameter, for example, you don't want to give DC, again it will run, but it will show outputs and expressions for only transient and AC. So the expression file is done, pressing enter to continue. Now it will again take a few time to check all the inputs you have provided through the template file. So here you have seen the design variables. Again, we have two design variables here, DC volt and AC amplitude. So let's provide the values for them, DC volt and AC amplitude. I want to continue with these values. So here you have chosen DC analysis. DC script type as component parameter. So firstly, for the easiness of the user, we have available sources has been displayed at the terminal. So user can enter, see the sources and which source user want to vary from his circuit, user can vary. So for example, I mistakenly enter a wrong source. So it will show an error that invalid source, please choose a source from the listed ones. So let's sweep the voltage V0 here. So for the parametric sweep, I want the start value and stop value. So giving the start value, DC sweep value as 0 and stop value as 1.2. So it has shown that you have entered the source name, start value and stop value as this. You want to continue or not? So as all the entries are correct, so pressing yes to continue. Now again for AC analysis, we have chosen the sweep type as frequency, but you can also give as component parameter and temperature also. So for sweep type as frequency, I want to give the start value 100 and let's take stop value as 100 gigahertz. Present enter, entering yes. So now here you can see only one netlist file is being generated because there is only one PVT setup here. So now again the results are being post processed. Let's check the output file at the last. Firstly, move to the plots. That if the plots has been plotted for transit, AC and DC, all three or not. So let's check for this. So now here you can see we have our AC plot, our DC plot. So here AC analysis has been run, plotted, DC plots also has been plotted. Now let's check for transit. So now transit is also being plotted. So here you can see using only one template file and one expression file, we can perform transit analysis, DC analysis and AC analysis, all three at the same time also. You can compare the results here. You can vary the PVT setups. You can give two simulations, three corners as per your needs. So after this, we can move to the output file. So here again, you can see we have only one PVT setup with the corner TT, voltage 1.2 and temperature 25. The results data bar is being presented here. And you can see here the expressions for all the expressions you have entered in the template file is being presented here. So this is how a project is being done. So now, if you are a new user, you doesn't know how to start the project. So what we can do is we have generated a help for the user. So for help, you can simply write EC and give the minus help switch. So by giving minus help switch, a help will be generated. We have made a dog file here. So in Firefox, a help will be generated where switch option with a proper detail is being presented here. Custom setup options, input requires via template, what inputs you need to require. There's a reference image also where you can check how we can enter the inputs, copy files, inputs check. The whole simulation process is being displayed to the user. Here also, I want to show you one thing that we have also provided the plot generation, that how our plots will work, and also the output file generation and the netlist generation. So this whole help file will help a user if he's a beginner, he does not know how to use our project, he or she can use our help PDF and can do his analysis very easily. So this is all how our project works. So thank you. This is the demo. So now I would like to invite my teammate Tanushika to close this session. I would also thanks to Pine Training Academy, my all scripting, analog and layout mentors who have provided me this skill set so I can showcase my talent in skill scripting and bash scripting in front of you. At last, this project gave me a lot of learning in using the skill command. And I've also learned that how to show a project, how to make the PPTs, help documents of the project, and a bit of how to handle the pressure while doing a project here. So now, Tanushika.
Thank you, Kavya. I would definitely like to thank Pine Training Academy for giving me this opportunity to enhance my skill, work on this particular project. I would like to thank my analog mentor, my layout mentor, my scripting mentor, my skill mentor to definitely make me the skill set that I would able to complete this particular project. And I would also like to thank my teammate Kavya for for doing the amazing coordination with me and helping me out whenever I got stuck at any point. So or the whole project given me a lot of learnings regarding my technical aspects regarding the Cadence Virtuoso e Cadence Virtuoso, and also the non-academic. As example, it helps me to develop the teammate skills and the coordination skills, and also definitely to handle the pressure. So thank you, everyone.